Not all polynomial functions have only integer zeros. Some can be irrational, some can even be complex. So we need to look to see if we can find those zeros that first of all are real, but also narrow down the field as to where we're looking when we can't seem to find them. To help with the location of zeros, we have something that is known as the intermediate value theorem. It says that if f is a polynomial function with real coefficients, and if f of a and f of b have opposite signs, then there is at least one value of c in between a and b such that f of c equals 0. Now let me put that to you in another way. What it is saying is, if you went from positive to negative, you had to pass through 0. On the flip side, the same thing. If you went from negative to positive, you had to pass through 0. So there is some value in between those two that you chose that gave you opposite signs. At some value in between those, you found your 0. Now, equivalently here, the equation f of x equals 0 has at least one real root between a and b. Okay, so if I chose 2 and 3, and up here I was looking for a 0, and I chose 2 and 3, and I got 2 to give me a positive number and 3 to give me a negative number, somewhere in between 2 and 3 I've got a 0. And that 0 is also called a root of the function. Equivalently, the graph has at least one x-intercept between those values. Okay? Again, it goes back to what we said about the zeros, the roots, and the x-intercepts all being connected. They only have a different name because it's a different way of looking at the function. If I'm looking at a function, I want to call it a 0. If I'm looking at an equation that I'm solving, I want to call it a root or a solution. If I'm looking at the graph, I want to call it an x-intercept. They're all basically the same concept, just slightly different connotation. So let's look at an example and show that there is a real 0 somewhere between -3 and -2 for our function. What I would need to do this is to substitute 3 for x, -3 for x. So I'm going to substitute -3 for x. And then I'm going to simplify. So -3 cubed is -27. -10 times -3 is +30. Then -3 times -27 is -81. And yes, you could do the 30 plus 9 and call it 39. But to follow the order of operations to the T, let's go left to right. -81 plus 30 is -51. And -51 plus 9 is -42. Okay, so I have a negative value for 3. -3. For -2, I'm going to substitute -2 into my initial function. And then simplify. So this is 3 times -8. -10 times -2 is +20. So this is -24 plus 20 plus 9. So this is -4 plus 9, which is +5. So see how my value crossed over from negative to positive between -3 and -2. Therefore, I know there's a 0 somewhere in there, and my guess is that it's closer to the -2 than to the -3, because I think 0 is closer to 5 than to -42. And just to show you that we did it correctly, here is the actual graph, and here's the crossing between -2 and -3. So we did the problem correctly, we made the correct assumptions, all just based on the intermediate value theorem.